All right, guys, HVO2, horizontal and vertical stretch or shrink. Titan says hi. He's a little bit annoyed today because I'm not paying him any attention because I'm doing this. But we kind of played in the backyard for like an hour, so maybe he should just be quiet. Okay, hopefully he will be for this video. So, horizontal and vertical stretch and shrink, certainly the two hardest things about transformations that we've talked about in the last week. So I guess the best idea for this is to just give you a couple of examples. So let's talk about f of x equals, let's go with a -3, 1/2 x plus 1 squared minus 4. We know that it's down 4. We know that it's left 1. Okay, so let's talk about a couple of things that are new for this video. Backtracking, that negative and that 3, they're two completely different things, okay? The negative sign is related to a x-axis reflection. What are you doing? What are you eating? What are you eating? Like, really? I don't even know what you're eating. Oh my god. Oh. There's literally nothing on the floor here, and he ate something. That doesn't make any sense. All right, yeah, you lay down. Okay. This negative and that 3, they're two different things. Even though it reads like -3 and then the rest of it, you have to kind of think of it like negative, pause, 3. Because they're two different transformations. X-axis reflection, this is by itself. Because this value is greater than 1, this is a vertical stretch of 3. Okay? Now, if this value was less than 1, it would be a vertical shrink of whatever it said. Truth telling. Okay. Inside the parentheses here, because it's next to x, it's something horizontal. Now, remember that it's a liar. It's a fraction where it appears to be a shrink, but it's lying to you, it's the opposite. It's actually a horizontal stretch. It is. I promise you it is. It's a horizontal stretch of 2. So what's happening is, it looks like it's a fraction, it looks like a shrink of 1/2. It's actually a horizontal stretch of 2. Yeah, I think he likes the limelight too. I think he just loves being in the camera. What are you even doing? Yep, okay. So let's do a couple more examples. Let's go f of x equals -1/4. 3x plus 1 squared minus 1. Okay. Down 1, left 1, x-axis reflection. Vertical shrink of 1/4. Truth teller, vertical. Horizontal shrink of 1/3. Okay? It's because this is a liar. It looks like it's a stretch because it's a whole number, but it's lying to you. It's actually the opposite. And the way that you can remember that is the number that's always in here is always the reciprocal of what it actually is. The reciprocal of 1/2 is 2/1, meaning stretch of 2. The reciprocal of 3/1 is 1/3, which is a horizontal shrink of 1/3. Now, the reason that this happens, again, I just want you to start to memorize this kind of thing, and we'll talk about the y in a second but for vertical. But for horizontal, the rule is f of x turns into f of 1/ax. And a, when it's greater than 1, it's a horizontal stretch. So what really is happening here is that the a value, the denominator, is what determines whether it's a stretch or a shrink. And I'm just thinking, make sure you can see that right. Okay, so when a, in this case, was 2, it's really the denominator that is trying to tell you what kind of stretch or shrink it is. Because the denominator is 2, because it's greater than 1, it is a stretch of 2 units. Now, this part is interesting because when we're talking about shrinks, the rule is still the same, f of 1/ax. When a is less than 1, it's a horizontal shrink. Now, here's what's interesting that happens to that. So in this case, we were talking about a horizontal shrink of 1/3. Well, a is 1/3, which gives us a double fraction, meaning 2 fraction bars. So this is what this will actually look like before we make the change and simplify. But you know you can't have a double fraction bar. So we're going to divide it. And I like to divide it old school side to side so you can see it. This actually says 1 divided by 1/3. But you know from, I don't know, whenever you learned it, you can't divide fractions. It's not possible. So we multiply by the reciprocal. So this turns out to be 1 times 3/1, which is 3. Which is the reason why there's a 3 there and not a 1/3. Woo! He was asleep, now he's awake.